Today, we're going to tackle something a lot of us have probably used but never really thought about how it works. Pastebin. Yeah, we're going to build one, right from scratch, right here.
I mean, think about it. The whole idea seems so simple, right? You've got some text, maybe a chunk of code, or some error logs, whatever, and you just need to share it. You paste it, hit a button, and boom, you get a link. It just works.
But what happens when it's not just you? What if 1 million people are doing that every single day? Suddenly that super simple idea turns into a huge engineering puzzle. How do you possibly build a system that can handle that kind of load day in and day out without just collapsing? Well, that's exactly what we're going to figure out.
Okay, so before we go any further, let's make sure we're all on the same page. A Pastebin, at its core, is just a web service that lets you store plain text and get a unique URL for it. That's it. The whole point is to make sharing that text quick and easy. That's the mission, and that's what we have to design for.
Right, so anytime you're designing a system that needs to scale, you've got to start with the numbers. You have to know what you're up against. The kind of load we expect is going to shape every single decision we make from here on out. We're not just building a little side project, we're thinking about a massive real-world service.
So, let's throw out a big number. Let's say we're aiming for 1 million new pastes every single day. 1 million! If you do the math, that breaks down to about 12 new pastes being created every second. That's our write load, and it's happening 24/7.
But of course, people aren't just writing pastes, they're reading them. And we're going to estimate that for every one paste that gets created, it gets read about 5 times. So that's 5 million reads a day. That's roughly 58 reads every second. This right here, this 5-to-1 ratio, is a huge clue for us. It tells us our system is read-heavy, and that's going to be super important when we start designing.
Okay, what about storage? Where are we going to put all this text? Well, if we figure an average paste is around, say, 10 kilobytes, and we have 1 million of those a day, that's 10 gigabytes of new data every single day. And if we keep that up for 10 years, you're looking at 36 terabytes. That is a mountain of text to keep track of.
So handling all that traffic is one thing, but the service also has to feel good, you know? It has to work the way people expect. First, it's got to be reliable. You can't have people's data just vanishing. It also needs to be highly available, meaning those links better work when you click them. And it's got to be fast. Nobody's going to wait around. And this last one is really important. The URLs have to be totally random, not guessable. The last thing you want is someone finding your private notes just by typing random letters into their browser.
Okay, we've got our requirements. We know the scale we're shooting for, so let's actually start building this thing. And the absolute foundation of any service like this is the data. But here's the twist. We're not dealing with just one kind of data. We've actually got 2 very different types to worry about.
And this is a really key insight. On one hand, you've got the metadata. This is all the small stuff, like the short URL, when it was created, maybe an expiration date. It's tiny, but we need to find it super fast. Then, on the other hand, you have the actual paste content, the text itself. This can be way bigger, up to 10 megabytes. This needs a different kind of storage, one that's good for holding big blobs of data, not necessarily for lightning-fast lookups.
You know, you could try to cram both of these into the same database, but it'd be like using a screwdriver to hammer a nail. It just wouldn't be efficient. The kind of database that's amazing at finding tiny bits of data quickly is usually not the best for storing huge chunks of text. So the smart move here, the key architectural decision, is to split them. We're going to use the right tool for the right job.
All right, next problem. And this one's kind of fun. Every single paste needs its own unique random URL. But remember, we're making 1 million of these a day. So how on earth do you generate all those keys, make sure they're random, and guarantee you never, ever create a duplicate? It's a fun little puzzle.
So you might think, why not just create a key right when the user hits submit? Well, that can be slow. And there's a small but real risk you might accidentally create one that's already been used. A much better way to do it is to have a dedicated service. We'll call it a key generation service, or KGS. Its only job is to just sit in the background, constantly churning out millions of unique keys and putting them in a database, all ready to go. And the process is super slick. So the KGS is just humming along in the background, making sure this database is always topped up with fresh keys. Then, when one of our main servers needs a key for a new paste, it just asks the KGS, hey, give me a key. The KGS grabs one, hands it over, and marks it as used so it never gets handed out again. No risk of collision, no delays. It's just simple, fast, and it can scale like crazy.
Okay, so let's recap. We figured out our scale, we've got a strategy for our data, and we've solved the unique key problem. Now it's time for the big reveal. Let's put all these pieces together and see what the final architecture looks like.
And there it is, the whole shebang, the complete blueprint for our Pastebin service that can handle millions of users. Now, I know, it might look a little intimidating at first glance, but guess what? We've actually already talked about all the most important parts. So let's just walk through it together, from the user all the way to the database. So, it all starts with the client. That's you, on your computer. The very first thing your request hits is a load balancer. Think of it like a traffic cop for the internet. Its job is to look at all the incoming requests and spread them out evenly across a whole bunch of application servers. These servers are the real workhorses. They're the brains of the operation. And if you're making a new paste, the first thing one of these servers does is reach out to our handy key generation service to grab a fresh, unique key.
Now we get to the real heart of the system, the data layer. This is where everything gets stored. So once an app server has the request and the key, it splits the data, just like we planned. The little bits of metadata, they go into a fast database, something like MySQL or Cassandra, that's built for quick lookups. The big chunk of text, that goes into a totally separate object storage system, like Amazon S3, which is designed to hold massive amounts of data. And to make things even faster, we've got a cache sitting in front of everything. It holds on to the most popular pastes so we can serve them up almost instantly. Oh, and one last thing, we've got a little cleanup service running in the background, just tidying up by deleting expired pastes.
So there you have it. We've walked through a complete real-world system design. But after seeing all these different moving parts, the load balancers, the KGS, the caches, the two different kinds of storage, what's the one big idea you should take away from all this? I think it's this: to make something that feels simple and easy for the user, you often need a whole lot of really thoughtful complexity behind the curtain. Every single piece we've talked about, every single box in that diagram is there for a reason. It's there to solve a specific problem that only appears when you're dealing with massive scale. It's all designed to make sure that the millionth person to use the service has the exact same fast, reliable experience as the very first.
And really, that's the thought I want to leave you with. This whole idea of simple on the outside, complex on the inside isn't just for Pastebin. It's everywhere. Think about something like a URL shortener or just hitting the like button on a post. They seem so simple, right? But what kind of crazy complex systems do you think are whirring away in the background just to make that one little click happen? It's something to think about next time you're online.